At the end of this video, you should be able to classify bonding type according to electronegativity differences.
A chemical bond is the force of attraction that holds two atoms together. As independent particles, atoms are at a relatively high potential energy. Most atoms are less stable existing by themselves than when they are combined. By bonding with each other, atoms decrease in potential energy, thereby creating more stable arrangements of matter.
Ionic bonds begin to form when an atom whose outermost energy level is almost empty transfers an electron to an atom whose outermost energy level is almost full. The two atoms are strongly attracted to one another and bond because this new situation changes the atoms to ions of opposite charge. Particles of opposite charge are attracted to each other.
Many atoms form covalent bonds. In covalent bonds, electrons are shared by both atoms. The first energy level in atoms can hold 2 electrons. By sharing electrons in a covalent bond, each hydrogen atom has a full outermost energy level. Water molecules are also held together with covalent bonds. Again, we see that covalent bonding gives each atom a full outermost energy level. The outermost energy level for hydrogen can hold 2 electrons. The outermost energy level for the oxygen can hold 8 electrons. In covalent bonds, the shared electrons move between the atoms that share them, forming a single electron cloud around both atoms. This diagram shows the relationship between the difference in electronegativity and the type of chemical bond between two atoms. The electronegativity difference between fluorine and cesium is 3.3. Because this is greater than 1.7, the bond is ionic. The fluorine atom has almost complete control of the electron, and the attraction between the two atoms is mostly electrical. The electronegativity difference between chlorine and hydrogen is 0.9. Because this is greater than 0.3 but less than 1.7, the bond is polar covalent. The chlorine atom has a greater attraction for the shared electron than the hydrogen atom. The electronegativity difference between hydrogen and hydrogen is 0. Because this is less than 0.3, the bond is non-polar covalent, and the two atoms share the electron equally.
Now let's practice what we just consumed and see if we can apply what we've learned and satisfy the objective at the beginning of the video. What I would like you to do is use the electronegativity values that are listed in figure 20 from the previous chapter in your textbook on page 161 and figure 2 in your textbook on page 176 to classify bonding between sulfur, represented as S, and the following elements: hydrogen, represented as H, cesium, represented as CS, and chlorine, represented as Cl. In each pair, which atom will be more electronegative? Once we have referenced the figures 20 and 2, we see that the electronegativity of sulfur is 2.5. The electronegativities of hydrogen, cesium, and chlorine are 2.1, 0.7, and 3.0 respectively. In each pair, the atom with the larger electronegativity will be the more electronegative atom. Going through the 3 pairs, we have hydrogen bonded to sulfur. We see that there is an electronegativity difference of 0.4, placing it squarely in the polar covalent bond type, with sulfur as the more electronegative atom. Then we see cesium bonded with sulfur, showing an electronegativity difference of 1.8, landing in the ionic bond type category, with, again, sulfur being the more electronegative atom. Then lastly, we see chlorine bonded with sulfur, the electronegativity difference there being 0.5, which lands in the polar covalent bond type. But in this instance, chlorine is the more electronegative atom. At this point, you should be able to classify bond type according to electronegativity differences.